So today I'll be talking about AI-driven programming education. So a few years ago, I visited a top school in a top city in India and had an opportunity to look at a collection of graded submissions from 5th grade students to an English essay problem. So one submission I looked at was graded 8 on 10, and the teacher had marked all incorrect phrases and also provided alternative suggestions. Another submission was graded 5 on 10, but the teacher had time to only indicate what was incorrect, but not provide any correction. And then one submission was simply graded 2 on 10 with no marking whatsoever. What is the child supposed to learn from this? We are still stuck with this centuries-old education model where one teacher caters to many students in a classroom, and hence the students cannot get personalized feedback. MOOCs make this problem even worse. So as a society, it is unlikely that we will be able to afford a dedicated teacher for every student. So what I want to propose is that AI can change the game. It can play the role of an always available personalized tutor to each student. So AI can also play the role of an assistant to a teacher. It can even mediate interaction between peers. For instance, it can connect students who are struggling with similar challenges. It can connect teachers with those students who are on the verge of dropping out. So let me now motivate why focus on programming education to start with, as opposed to some other subject. So first, there is increasing realization about introducing computational thinking in schools. You know, the deepest level of learning happens when one creates something that is meaningful to them. And programming is a construction material, just like blocks or chemicals, but infinitely malleable, that can enable creative expression or can enable solutions to hard problems that lead to meaningful impact. Whether it is the field of art or science, math or physics, robots or games, we are not limited by the strength of wood or the budget of the school workshop. In programming, we are limited only by our own ability or inability to manage the complexity of our creation. But unfortunately, programming remains an optional subject at schools and is not even available at all schools. And this further contributes to the privilege gap. Secondly, the demand for computing skills has continued to increase, with more than 2/3 of all tech jobs present outside the tech sector. There are many more students who want to take CS courses than we have our capacity in colleges. Most employers across various countries can't find enough talent. And this problem will only worsen as AI displaces mundane jobs. We need to empower people with tools for creative jobs, and programming is an important part of that toolkit. And then finally, programming is a unique subject, logical like math, but creative like language arts, and requires hands-on training like sciences. There is no unique solution to a given problem, and hence it is not easy to check the correctness of a student's submission. So hence grading and giving personalized feedback to students is hard, time-consuming, error-prone. And today's programming toolkit caters to professional developers, and it is very far from the challenges that learners face. We see 80% dropout amongst US minorities in introductory programming courses. Now, let me explain how AI can transform the learning experiences of students. The first challenge that students face when learning programming is to deal with unforgiving and sometimes unnatural syntax requirements, as you would notice in the two scenarios here, where the student missed just a single character. And you know what makes this worse is the unhelpful and confusing error messages that computer generates that probably only a professional can appreciate. Syntax repair techniques can actually form the basis of giving feedback to students here. So some of my own work in this space has actually been done in collaboration with Amay and his students. So let me show you a concept demo.
As an instructor, I would want students to become independent computational thinkers and solve problems on their own. For students, a big part of doing that is having students carefully read the error messages they see in their editor to solve their problems. Frustratingly, we found that these error messages were often cryptic and extremely unhelpful to novice learners. These messages used mysterious jargon, and sometimes the error messages didn't even point to the right problems in the first place. Our research has found that even in successful cases, it can take many minutes for students to resolve these types of problems. And that's assuming that they don't have to reach out to the instructor or TA, in which case it can take the students several days to solve what was ultimately a simple issue. Worse, confusing error messages have been shown to significantly hurt students' self-confidence and even lower their interest in pursuing computer science at all. To address these challenges, we've developed an intelligent and adaptive feedback tool to set the student up for success. Alright, let's start a demo. What we see here is a typical problem in CS1 called the rainfall problem. And here the student has made a reasonable attempt, but nevertheless, the code has a number of syntax errors which appear as squiggly lines in their editor. For purposes of this demo, we have errors in red, which are the errors the student would see if they went to the VS Code website right now and downloaded the editor. The errors in orange are our AI-based adaptive error message feedback, and in a real system, of course, you wouldn't want to show the student both simultaneously. This is just for demo purposes. Okay, so let's say I'm a new student. Let's look at some of the error messages we give today. I'm going to go over here to look at what's wrong with this count. And Pylance tells me expected colon. Even as an expert, I don't think this is right. Changing count to colon is not going to solve my problem here. Okay, so let's look at another one just to make sure. So this one says expected closing parentheses. And this is kind of confusing to me too, because it looks like I already have an opening and closing parentheses. So I'm not really sure what is wrong here or what I'm doing here. What could we do differently to better help our students? Let's now look at our AI-driven error messages, which are designed to support student learning. Okay, so let me take a look at this error from our system. Oh, interesting. So it says Python couldn't understand your program. Look closely at the left and right sides of the assignment statement. So it didn't give me the answer, but it's giving me a hint. And it gives me a second hint as well. It says there's another part in your program where you have actually done this correctly on line 8. Okay, that's the line right below. Oh, what a silly mistake. All I had to do was, instead of saying sum plus a equals sum, I should have reversed it and said sum equals sum plus a. Awesome. Okay, let's look at one more down here, which seemed right to me based on the parentheses. It said, okay, again, Python couldn't understand your program. It looks like you're trying to call print. Yep, I am. And I am calling it with multiple arguments. I have the word average and the variable avg. What do arguments need to be separated by? Oh, I have a space. Function arguments need to be separated by a comma. Okay, great. I'm going to add that and move on. Now, eventually, as our students get better, we won't need to give them such long explanations and scaffolding. So too can our system adapt alongside them. So let's go ahead and choose PyEdu, and here we have set feedback style. And what we're going to do is we're going to switch the feedback, which is currently in learning-oriented mode, and we're going to switch it to expert to give repair-oriented feedback to help the student simply solve the error message much more quickly. Okay, let's see what the feedback looks like now. The feedback directly shows me the problem, which is great, and also enables quick fixes for each of these problems. So I can go here and do replace, and that gets replaced. I can go up here, hit replace. This else was an else if. Awesome. I think I was missing a semicolon here. Go ahead and take care of that for me. Since I already understand the concept, now it's just having a great system take care of these nuisance typos that I've made within my program. In summary, our AI-driven error message technology can help provide contextual feedback to meet learners where they are, but also adapt as they grow. Early on, we believe these enhanced error messages will significantly improve learning and reduce frustration. Later on, these messages become productivity multipliers that allow students to get past syntax errors quickly and focus their effort on more interesting concepts in computational thinking.
Okay, so that was a concept demo on giving feedback on syntax errors. So after syntax errors, the next challenge that students go through is the edit debug cycle until the code passes their test cases. And this is where most time is spent, even for professionals. Checking program correctness is undecidable, and there can be tons of different ways to solve a problem. And the state of the art that we use today in evaluating a student solution is to execute it against a set of hidden test cases. And now if a student gets 4 out of 10 on their assignment because it passed 40% test cases, what are they supposed to learn from it? Providing them a sample solution is not sufficient, because what they really need to know is how their solution, which reflects their thought process, can be lifted into a correct solution. So this inspired an interesting problem definition for us. Find a minimal repair to a student's code to make it pass a given set of test cases or input-output examples. We have leveraged several different ideas to identify such repairs. One idea that we initially explored was to search for edits over an underlying repair language. Another idea we experimented with was to leverage expressions from other student solutions. Yet another idea has been to leverage past teacher corrections for similar mistakes. But unfortunately, all these ideas have remained captured in research papers. More needs to be done to make them robust and take them inside real classrooms. However, this last idea of leveraging similar teacher corrections, we actually took it to the real world, but in a different context of improving developers' productivity. So let me show you next what we did. Developers spend most of their time not authoring new sophisticated algorithms, but in software engineering tasks, such as refactoring code, writing plumbing or templatized code, or performing repetitive edits to fix bugs or performance issues. So these edits, these repetitive edits, they are not the same, but they are similar. So it's like, say you have a Word document with dates in US format, and you want to replace them by respective dates in Indian format. So once the user makes a couple of these edits, we are able to suggest related edits at all the other places where the user needs to make similar changes. So this program synthesis technology ships as the IntelliCode suggestions feature in Visual Studio. The key challenge that we addressed here was to infer the user's intent from a few example edits that are provided not explicitly, but implicitly. So these edits are hidden in their natural and noisy workflows. The developer simply goes about doing their task naturally without getting into any mode, while the underlying engine watches, learns, and makes suggestions. So this feature is gaining increasing adoption with few million accepted suggestions per month. And these are some of the tweets that developers shared when they were emotionally moved by the magic of this feature. So this is when we know that technologies like these are shaping the future. So let me show you a demo of this feature next.
Hi there, I'm Peter from the IntelliCode team. Today I will show you some exciting new features in IntelliCode Suggestions. As a developer, you make repetitive changes all the time. You might not even realize how much you're doing this. From now on, IntelliCode Suggestions will make those changes frictionless, blending into your normal workflow. When IntelliCode detects a possible repeated edit and you start typing at the next occurrence, the suggestion for doing the repeated edit appears right there in the completion list. When you select the completion, you will see a preview of the edit we are suggesting. How cool is that? After you apply the suggestion, there's even more. When there are more occurrences of the same suggestion in your code, we will give you a follow-up light bulb. Just by opening the light bulb on the current line, you can quickly jump to the next suggestion and even apply them all at once. To make this even easier, you can do this right from your keyboard with preview key bindings. Ctrl-Alt will apply the suggestion directly. Ctrl-Alt, will take you straight to the next occurrence. The UI shows clearly what is changing. So case-by-case reviewing is a slick and painless experience that puts you fully in control at every step. You can enable this in the IntelliCode preview features.
So as was suggested, you can actually try this thing yourself. And we make all our APIs available for public, non-commercial use on our websites. Now, an interesting question for this audience is, how can similar technologies be leveraged in the education setting, where these similar edits are not inside a single developer's code base, but the similar edits are actually spread out across different student programs? Now, moving beyond syntax and functional errors, a student solution can pass all test cases, even if they use non-optimal algorithmic strategies, and hence they can miss out on a key aspect of computational learning. So for instance, consider the problem of checking whether two strings S and T are permutations of one another. So one student here on the left has sorted the characters in the two strings. And this student can actually be suggested to instead count and compare the number of occurrences of various characters to make their code more efficient. And then this student on the right is actually using this counting strategy, but in a non-optimal manner inside a loop. And to this student, you can provide a feedback that you should try to amortize the counting cost in a pre-processing phase. So this motivated us to develop techniques that can classify the student solutions into one of predefined higher level strategies, each of which can be associated with the teacher provided feedback. And this classification is done by simply observing the intermediate values that the student's code computes. So that's the key idea here. So what we figured out in our experimentation was that these intermediate values turned out to be a good signature for automatically identifying the computational strategy that was being used by the student. However, as I mentioned before, all these techniques that I try to impress you with, they are just prototypes, and more development is needed to make them robust. However, one success story in this area has been our Automata tutoring tool. This tool has been used by more than 10,000 students at 30 plus universities across most continents. This tool generates different kinds of feedback for automata construction problems depending on the mistake. For instance, for the first submission that we have, the first feedback here corresponds to a comparison with the edit distance. The second feedback here is based on a counter example. And the third feedback is based on automatically identifying that the student solution is actually a correct one, but for a slightly different problem. So depending upon the mistake, the tool gives different kinds of feedback to students. So a famous instructor said that this tool not only saves hours, but is also much more fair than human instructors, and that he would never go back to manual grading. Another instructor said that this is how automata construction topic should be taught in a modern way. And they wish that they had similar tools for all the topics they needed to cover. And I believe we have the potential to achieve similar success for programming education. So I would like to now propose a grand challenge of developing a feedback or hint generation AI bot that is indistinguishable from a human teaching assistant, and whose feedback quality is voted on by the students receiving feedback. And the way that we will evaluate the utility of this AI bot is by deploying it in real classrooms. and demonstrating that this actually improves the student learning. So which means that more students will follow through their programming courses, less dropouts. And the students will come out of these courses with better programming skills and in a shorter span of time. And by virtue of a shared challenge like this, I think we have an opportunity here to solicit international cooperation and nurture a research community in this area. So first, we have the opportunity to partner in gathering data that is related to student attempts as they attempt programming problems, and any feedback that any teaching assistant provides them. And secondly, we should develop open source infrastructure and tools that will allow researchers to build on each other's work. In fact, I also believe that our success shall inspire the startup market in education technologies in right directions. And this market is expected soon to be worth more than $6 trillion. Now, in general, reasoning about computer programs is undecidable. However, what makes our setting tractable is that we have to deal with only small programs, which are few tens or hundreds of lines, as opposed to millions of lines of industrial code bases. And the small size instances will pave the way to developing techniques that can perform deep and precise symbolic reasoning of programs. And we also have the advantage of leveraging data. Tons of potentially labeled attempts to similar or even the same set of programming problems by students from around the world and year after year. And this will pave the way to building over recent advances even in data-driven techniques. Another challenge is the fact that we not only have to reason about programs, but we also need to reason about student minds. And different students learn differently, and we have different confusions or misconceptions. But here we can leverage the past journeys of a diverse set of students and their potential interaction with teachers. We can understand optimal pathways. We can figure out what worked and what did not work. And we can use that knowledge to guide new students. And here we can view the teaching process as a cooperative two-agent reinforcement learning problem and build over recent advances in deep learning-based RL methods developed for gameplay. So the programming languages and software engineering communities have invested a lot in repair techniques. And I think it is time to reinvest in this area, but in the context of programming education. Being able to repair the student solution into a nearest correct solution or the next logical step that they should be taking can form the basis of generating personalized feedback and hints for students. A lot of my own expertise is in the area of program synthesis or automatic programming. And next, I wanted to talk about some innovations in this space. And this is because I believe that some of this can also inspire new pedagogies for programming education. So let me explain what I mean. So some 10 plus years ago, I was flying from Frankfurt to Seattle, returning home from a dark school workshop. And there was a lady sitting next to me. She was impressed to know that I had a PhD in computer science and that I worked for Microsoft Research. So she wondered if I could help her with a problem that she was struggling with. She opens up her laptop, fires up Excel, and points me to a column of names and asks me, how can she extract the last name into a new column? Now, normally I would program such tasks using regular expressions, but at that time I had no idea about the programming model underneath Excel. So I had to sheepishly excuse myself out of the situation. So after returning home, I searched for a solution to her problem on Excel help forums. And it is then that I realized that there were many people who struggled with simple repetitive tasks like that of the airplane lady. So these people would solicit the help of an expert on a help forum, and they will communicate their intent using input-output examples. Unfortunately, such interactions would spend several days and sometimes even require multiple rounds. So for instance, consider this task of mapping the student name and the student ID to their password. So in particular, you need to extract the first initial of the name, the first 4 characters of the student ID, and then lowercase the last name, and concatenate them with the delimiters dash and pound. 99% people who use computers do not know programming and they would be stuck. But they can easily describe their intent in such cases by simply giving an example of what they want. So this inspired me to develop the Flashfill feature in Excel. So when you provide one or more examples, Flashfill generalizes the examples into a program in real time and executes that program to automate your task. So this feature turned out to be quite popular with around 1 million invocations per week. And the key scientific breakthrough here was to learn the user's intent in real time and from just one example in most cases. So my child Sumay, who recently turned 8 years old, has often asked me, "Dad, you are a scientist, right? What have you invented?" A surreal movement arrived last year when I was able to answer just that. His remote schooled second grade class had been using many digital applications, each with their own usernames and passwords that had been set to some function of the student's name and ID. And these credentials were communicated by the teacher in a mass email by sharing an example of the rule that is to be used to drive these credentials from the student's name and ID. Just like what you see in the first data row in the table. From one example, the student is supposed to infer the rule and apply it to their name and ID to construct their password. So I showed Sumay how Flashfill was smart enough to solve such analogy challenges. A few weeks ago, my sister, who is a medical doctor in India, called me up and told me that she proudly explained the Flashfill feature to my nephew, who found when she found its mention in grade 6 CBSE computing textbook. That I thought was special. After all, how many of my inventions will define the content of middle school textbooks? Next to this page, the spreadsheet lesson also contains some description of the Excel formula language. And I think this is a beautiful opportunity to connect the two together. That is, use Flashfill as a way to introduce some operators of the Excel formula language. So while Flashfill does not allow this today, it does not show you the readable program underneath. We are actually working on a new version that will also show you the underlying formula. And even more, this technology can generate readable formulas in other languages like Python as well. So from either of these cases, you can easily learn how substring extraction can be performed using indexing, how indexing can be done with negative integers as well, how the split operator works, how to perform lowercase, and how to concatenate the various substrings. So if any one of you is interested in pedagogy related to using Flashfill to teach string manipulation, please do get in touch with me. Another domain that we have developed programming by example techniques is in the space of extracting tabular data from semi-structured documents, like custom text files, web pages, or JSON documents. So for instance, consider this custom text file. Suppose you want to extract tabular data out of it for doing some analysis. So normally this would require you to write a custom parser, which can take a lot of time for even professionals. So instead, our program synthesis techniques allow the user to describe their intent by simply giving 1 to 2 examples of the various fields that they want to extract: the blue field, the green field, the yellow field. And then the intended parser is automatically synthesized from that specification. And these innovations actually ship as data connectors in Microsoft's Power Query product. And recently we were heartened to see their usage to build dashboards for various COVID-19 datasets. I believe that these techniques can perhaps be pulled into introductory data science courses as well. Now, while examples can be a natural way to communicate computational intent, some tasks are best specified using natural language. Consider, for instance, this data table that shows the hourly pay details of different people. So suppose one wants to figure out how many hours were billed by cashiers in Capitol Hill. Now, these kinds of tasks are best described using natural language. But a key challenge in this space has been to handle the variability in how different users may say the same task. So this led us to a few papers, one of which I even have Amay as a co-author. Now there is a new kid on the block OpenAI has developed a very powerful pre-trained language model called Codex that has captured the imagination of the world as it predicts code fragments from natural language. And GitHub has developed a wrapper on top of it called Copilot. And this, I believe, shall redefine use and adoption of natural language in programming. And for this audience, I think it also opens up interesting potential of doing some experiments in pedagogy as well. Now, if we can demonstrate the feasibility and utility of personalized feedback generation for programming, I believe that it will also inspire development of personalized feedback generation technologies for other subject domains too, such as math, physics, language arts. In fact, our techniques for helping students learn programming will also extend to enabling professional software developers be more productive, and in fact lay the seeds for the next programming revolution. So if you look at the history of programming, we see programming evolved from punched cards and assembly language to now high-level languages and beautiful code editors. The next programming evolution will take it closer to human conversation, involving multimodality, such as use of examples and natural language to express intent, and involving interactivity, wherein a computer will act as a pair programming agent, much like an extension of the AI bots that I propose for programming education. A few months ago, Surya was solving a math problem in a second grade class. Find all tuples A, B, C, D such that A, B, C, D are distinct digits and A times B equals C times D. For example, 2 times 6 equals 4 times 3. So after he exhaustively enumerated all the 40 solutions, I teased him. Do you know a computer could have done this for you? You just have to tell it what to do. And his eyes lit up. And he got inspired to try out his first textual computer program. So I pulled up an online Python site and walked him through some simple print expressions. And then we start writing the loopy program for this task. And he's holding his breath, watching the screen for the solution to appear. Except that I have never written a Python program in my life before. But with 25 years of programming experience, I'm confident I can figure this out with the help of error messages. But no, I failed. I tried many different syntax, but the error messages remained cryptic. My child finally asks me, Papa, are you sure you know programming? Ultimately, I had to look at the documentation. And of course, then it all worked. But most people would have been able to figure out my intent from my imprecisely written program. And if computers can understand such sloppy programs or pseudocode, it will transform programming education, and the same innovations will also help seed the next programming revolution. And if this motivation seems too earthly to you, think about the frozen embryos approach to interstellar travel, where one of the theories is that we put frozen embryos on spaceships, and when they reach planets that can be inhabited, the embryos are brought to life. But we need educational robots to educate the babies when they come to life. Now, on a more serious note, let me conclude the technical content of my talk by observing that change in education is difficult and slow. But the disruption that COVID has brought to our education system is an unexpected and rare opportunity for us to correct the course. COVID has driven home the importance of unsynchronized learning, something that makes receiving personalized feedback even more challenging. COVID has led to increased digitization of educational processes, which will actually make it easy to incorporate AI-based technologies. So if you would like to participate or collaborate in this research with us, please do get in touch with me. Now, before concluding, I wanted to put in an advertisement for our India Research Fellowship Program. So this is for students who are finishing up their bachelor's or master's program. It is a 2-year program of temporary employment, just like the research fellow program that Microsoft Research and Google Research in India runs. However, after those 2 years, instead of leaving for a top PhD school in US, there may also be an opportunity for you for a full-time position at Microsoft India to continue as a research assistant with our team. And then after 4 more years, depending on your achievements and interest, we may actually onboard you onto a researcher role at Microsoft. Or else you continue your journey as an engineer at Microsoft. So please do visit my team's career page to learn more and apply. And then from your perspective, this can be an alternative to a PhD program at a top US university. You will receive very unique research training along the lines of our research culture that I will describe on the next slide. And then from our perspective, we jointly get to generate accelerated scientific and practical impact. So, it is not difficult to write papers in top tier conferences. Once you learn the game, you figure out that most academics, do that. It is also commonplace to write code that millions of people use. Most office developers, will raise their hand and lay claim to that. However, it is a privilege to work at the intersection. That is on problems that lead to top tier publications and affect the lives of millions of people. And if that's a success metric that you want to aim for, then I will share with you 4 ingredients of our research culture that go behind delivering a great end-to-end experience around a magical AI technology. So it starts with picking the right problem. And this is what I call customer connection. Identifying your customer pain points through a study of help forums, customer interviews, and even analyzing relevant telemetry information in your product. Flashfill was the most important turning point in my career. When I went from searching for the hardest problem I can solve to searching for the simplest problem that will have the most impact. While it took me 3 weeks to develop a first prototype of Flashfill, I had spent 3 months studying the spreadsheet help forums to identify the right nuance of the problem definition behind Flashfill. The second aspect relates to engaging in cross-disciplinary research, which I believe has higher chances of achieving disruption. Most people who call them AI researchers may belong in one of 2 camps: logical reasoning, which characterize the first wave of AI, and machine learning, which has been the defining aspect of the second wave of AI. So I believe that the next big revolution in AI will be built on interesting ways to combine logical reasoning and machine learning techniques. Another realization I've had is that it is absolutely important to invest in developing good user experiences around your technology, something that avoids the discoverability issues and makes it usable, and thus results in adoption by millions of users. And paying attention to user experiences not only makes the technology more usable and leads to great adoption, but even more interestingly, for us, it has inspired foundational advances in the first place. So while it is good to be an expert in one research area, it is better to also be an informed outsider in other research areas. The third aspect is around being able to create a good implementation of your ideas. So if you leave your research papers for someone else to implement in the future, why would other people believe in your ideas if you did not believe in it? And this is where research and engineering meet. Research is about embracing uncertainty, but engineering product delivery is about removing uncertainty. And these opposing values, when you connect together, actually lead to better innovation. So when I was working on Flashfill, it was the Excel team's strict requirements around efficiency and ranking effectiveness of the underlying synthesis technology that inspired the novel technical solution behind Flashfill. And the last aspect is around doing foundational work and developing framework-based approaches as opposed to investing in many disparate point solutions. Good science is about layering, building on the work of others, and contributing to the success of others. So to summarize, the 4 things that I talked about were sensitivity to customer connection, cross-disciplinary scientific expertise, expertise in software engineering, and being able to do deep foundational work. And now you might say, Sumit, what you're describing would be a unicorn. Agreed. So let me top it off with this final advice. Be part of a diverse team, a team that has diverse scientific talent and people with diverse roles. Cross-disciplinary researchers and engineers working together with program managers and user experience designers. So that's my secret sauce as Microsoft. So all the work that I have described today is done in close collaboration with many of my talented, extremely talented colleagues. And I feel privileged to be part of my fantastic team. So come and be part of it. Thank you.
Thank you, Sumit, for this wonderful talk. So I have one question that I will read out. In the meantime, I request other participants to type their questions in the Q&A box. So the question is from Atul Kumar. He says, great tools, just a philosophical question. So it came when you were describing compiler error repairs, just after that. So like with spell check, I no longer bother to make sure I am typing correct spelling, as I know the spell check will show it. That has made me not to learn new spelling or fixing the ones I don't remember correctly. Will technologies like this not do the same thing to the students at early age? They may not bother to understand syntax properly because they know it will be fixed. Or is that the objective? Why to bother about the syntax, etc., when you can spend that time in solving the higher problems?
So I think the answer is in the question itself, right? Which is that this is not very different from what do you think of technologies for giving you corrections on spelling errors, or what do you think about use of calculators? So should we not teach multiplication, division to our kids? So in fact, this last year we saw that even kindergartners were actually using Microsoft Word. So I could, so my child just sits next to me, on this white desk that I have, and I was seeing that whenever he would type something in Word, he will get all those spelling errors. And my immediate reaction at that point was that this feature needs to be stopped, right? So this feature needs to be stopped. These products that we now have, they were never meant for learners in the first place. And now what this pandemic has shown is that the boundary between professionals and learners is becoming thin, whether it is children or whether it is even adults who will need reskilling. And these products have to be redesigned from that notion of inclusivity. And in my mind, the right thing to do is that this kind of intelligence that we believe is fundamental and core should be turned off inside these products, just like what you were seeing in Titus's demo, the concept demo that I actually showed, where the intelligence was being surfaced as hints and not the right result, but just as hints when the child was getting stuck. And when the child develops mastery on a particular concept, then you turn those features on to help improve their productivity. And I think this is what should happen with spelling error suggestions, or with use of calculators, or with AI that now goes beyond syntax errors, and we don't need to worry about syntax errors in the future.
Okay, thanks, Sumit. So next question is from anonymous attendee. It's about, is IntelliCode available only for Visual Studio, or is it available for other editors as well? Also, what other programming languages does it support? If time permits, can you also throw some light on AI part of the IntelliCode? I think the second part, I don't think time will permit, but can you tell about IntelliCode, where all it is available?
So IntelliCode provides different kinds of intelligence. The intelligence that I showed you in the demo is a feature called IntelliCode Suggestions, where it gives you suggestions on what you might be typing next based upon patterns that it has seen in your code base in the past, or the edits that you have done in the recent past. And now we are also extending this capability to provide other kinds of suggestions related to refactoring. Then IntelliCode proper is about giving you suggestions on the next token that you're trying to write, or the next line that you're trying to complete, which may not necessarily be based upon any repeated edits, but it is based upon knowledge and that it has gained from looking at lots of source code that is out there. So in a sense, similar to Copilot, how it is predicting the next thing that you're trying to write down, and that wisdom is obtained by learning patterns over huge amounts of data and building these powerful models. So will IntelliCode as a service be made available for other editors? I cannot comment on that now. What languages does it support? IntelliCode suggestions today is focused on C#, but some of the other features of IntelliCode are also available for other languages. But your observation is absolutely right, that once we put this technology out there, we will try to broaden the scope to cover all languages. We will broaden the scope to all surfaces. But right now, still, there's a huge opportunity in terms of developing this form of AI, even for one programming language. And I take great pride in us being able to repeatedly iterate on the experience with the student and the feedback that we get. But once these technologies become more robust, absolutely they should be released, for many different languages and in many different surfaces.
Okay, thank you, Smith. So next question is by Deepti Reddy. Does giving more simplified feedback will also help students to interpret the actual compiler error?
Absolutely. So compilers were never designed for learners. Compilers were always built for professionals. And the challenge with compilers is that they have to take into account all different kinds of corner cases. So when you look at a buggy program, you are immediately able to probably figure out what is going on or what should the repair be, because you are assuming the context that it is a student who is writing this program, and it is an intro programming course, and this program is being written for these simple programming problems, and hence this should be the fix. This is a job that compilers cannot do, because they have to guarantee 100% correctness, for all possible cases. And the opportunity that we have here is to realize that what students need is a technology that will be 99% accurate and is likely going to be the correct thing in the limited vocabulary that the student is dealing with. And this is where AI comes in. This is where it becomes an AI problem as opposed to a compiler problem. And the feedback that we would like to generate for the student should be along the lines of what a human teacher would have provided. So this is what I'm calling out, right? That we need to collect a lot of data and partner with people in pedagogy to figure out what is the feedback that you will provide to the student. So you will not always provide the repair to the student. In fact, you want to provide them hints. You want to tease them to keep them interested enough, but also let them struggle, because a lot of learning actually comes from, you struggling with things. In fact, two students who have made exactly the same mistake may need to be given different feedback. One student has just struggled with the problem for 2 minutes. Another student has been stuck with it for 30 minutes. Or you might have talked about a similar kind of feedback in the recent past with the student. And then you might want to remind the student of this other experience in the past. So the feedback generation technology should be a function of not just the student's attempt at any given point of time, but also their learning journeys as well. And what form should this feedback take? This is what people who are good teachers, who know pedagogy, should tell us. And then the goal of AI should be to try to come close to that as much as possible.
Thank you. So I will just skip a couple of questions because the next question is related. So this is by Vinu Varghese. Will providing feedbacks temper the natural flow of trial and error that the students learn when he or she corrects the error themselves?
So again, the answer is in the question itself, right? So what I'm saying is you give them the feedback exactly how a human instructor would have done. So if the human instructor believes that at that point of time, given the pace of the student and their past, learning journeys, they should rather be, just left on their own, try to continue to iterate until they get it right. Let it be, that should be the feedback. No feedback, at that point of time. What should a human do? What should a good human teacher would have done at that point of time, is what the AI should do. Because a human teacher is not available to give personalized feedback or one-on-one coaching to students. And in most places in the world, you don't even have, access to good teachers in the first place. So I'm not suggesting here to redefine pedagogy. Absolutely not. Actually, the second part of my talk was about that, right? But for the first part of the talk, what I was saying was, you folks, who have been teaching this content, who understand the students, learning journeys the most, you folks should define the pedagogy. And then the goal of the AI should be to try to come close to implementing that pedagogy. So that's one. And then the second part of the talk, I was suggesting that with the recent innovations in program synthesis and programming by examples, programming by natural language, maybe there's also an opportunity to start thinking about new pedagogies, where, for instance, people maybe, let's say, we're not even talking about students, we're talking about adults who already know 10 programming languages, and now they have to learn a new programming language. So they can just say, hello world, right? Input is nothing, output is hello world. What is the program? And they slowly, use programming by example systems or natural language systems to educate themselves about the nuances of that programming language. So that part was about helping define new pedagogy, think about defining new pedagogies. But the first part of my talk was about understanding the right pedagogy, collecting that data at large scale, and then training models which can come close to providing that experience that a good human teacher would have provided.
Thank you. So there are 4 questions, open questions. I will ask them and now stop taking any more questions in the interest of time. So the first question is by Venkatesh Chopela. What is your opinion about the connection between the ability to articulate in natural language and ability to write programs? Should we focus on composition in natural language to teach better programming?
So that's an interesting point, right? And again, my opinion would be quite naive here because I have not formally taught. But my feeling is that these are 2 different aspects. The notion of computational thinking, which is to split the problem down into a bunch of sub-problems and put together their solutions to solve the original problem, is a different ability than the ability to be able to write down a syntactically correct program. So what you're suggesting in natural language, or maybe let's say pseudocode language, would be very appropriate for teaching that kind of computational thinking and being able to be very precise and write the syntax correctly and so on. I feel might be a different skill, and both might be important. But let's say in the future, programming languages evolve to a state where syntax errors are automatically taken care of. Sure, maybe we will not necessarily need to teach syntax in that detail. But I feel there's another aspect that goes with it, right, which is about making things more formal. And another interesting aspect is about proofs, being able to correctly prove the correctness of your code. And this is where details are important. So maybe I would say the knowledge of syntax is more related to developing your skills around details, when details actually are important in some setting in life. So details versus computational thinking, 2 very different things, probably can be separated. But I think there's an interesting point there, which is about can pseudocode actually be used inside classrooms to teach, and especially for beginner students. So people are experimenting with block-based languages, very, very fine concept. Pseudocode might be another fine concept. And then you will have to onboard them to real programming languages. And it just depends, what state the technology is in terms of being, how sensitive is it to syntax errors? Can it fix it on its own or not? Maybe this will take a few more years, for us to get to that stage.
Next question is by Gagan Garg. We are using HackerRank this semester for automatic evaluation of Python code written by students. It checks the number of test cases that the program passes and assigns marks accordingly. Is there a better way to automate code evaluation?
So it might very well be the case that the student was not good in thinking about making test cases on their own, but their attempt was mostly correct, except one, I'm just making it up, right, but except one small detail, but it ends up failing 90% of the hidden test cases. Then giving them 10% marks, I don't believe is actually fair. But then what can you do about it? This is the state of the art in how you evaluate the correctness of student solutions today. So my general thinking is that yes, we can definitely make it better. And just to give you another example, let's say the student's code passes all the test cases, but it is not very elegant. It's not as elegant, right? Maybe it is not a very efficient way of solving the problem. So how are you going to catch that with your small set of hidden test cases? So again, this requires us to develop a more fundamental understanding of what the student is attempting, and I believe this can be done. And this can be done because this kind of deep reasoning about programs, we are not talking about developing technologies that will work on millions of lines of arbitrary code bases. We're talking about developing technologies which can do deep semantic analysis of programs for small programs, and for programs whose specification is known, and for programs for which we have seen lots of attempts in the past, correct solutions, incorrect solutions, and so on. What I would actually urge you is help contribute to this research, collect that data, gather that data, and remove the PII information from it, and then try to donate it, for the kind of research that we want to do in this space.
So next question is by Dr. Veer Bahadur Singh. How machine learning will be applicable in bug localization?
So again, that's a hard problem to solve in general. And there we do not really understand, right? It's a very hard problem. But in the context of student submissions, we are dealing with small programs. We are dealing with problems whose specification is known. We're dealing with programs for which we have seen many different attempts in the past, many of which might have gone through manual grading. Students year after year around the world are learning with a similar set of programming problems. So when the new year comes, you don't have to make a new set of programming problems. You can reuse the previous set of problems for which you have gathered lot of data. And this will form the basis of developing super duper intelligent techniques, which can do bug localization, which can give you feedback messages, just like a human instructor would have actually provided. So I have huge hope. I'm very bullish on us being able to do very deep semantic analysis in this world of programming education.
So last question for this session, it's by Arpita. Sir, have you done any assessment of the improvements in the learning of the students?
This is the success metric that we want to aspire to. And most of the program synthesis technologies that we have developed have shipped through Microsoft products, being used by millions of people. And we keep iterating on them and improving the experiences. And I declare that a success. Most of my work on education, which I've been doing for the past decade, has unfortunately only been inside research papers. The only user study that we did, comes close to is in automata constructions. But for programming languages, unfortunately, I have myself not participated in any of these studies. And even if you see any studies which say that these things don't help, please do not read much into those studies. All that they are saying is that the tool that the researcher had at that time, that tool was not smart enough. I am extremely bullish on us being able to develop intelligent tools, and these tools will actually improve the learning experiences inside real classrooms. We are not there yet, but we are ready to actually take on this challenge and develop these technologies and start deploying them in classrooms to see little benefit here and there, and then build up on it. So the answer is no, but I'm extremely bullish that this can be done if we get our act together, if we collaborate together, if we partner together. Partnership between different kinds of AI scientists, people who have expertise in machine learning, people who have expertise in logical reasoning, partnership with teachers, partners with people who are experts in pedagogy. So I believe we can do this, but sadly the answer today is no.
Thank you, Sumit, and we are closing our session now. So we'll have a break session. And I think before close, I will request Chitra if she can contact Sumit and have a webinar by him.
Definitely. I would love that. Hello.
Yes, Chitra, we can hear you.
Yeah. I would love that. I would get in touch with you, Sumit. It was a great talk. So definitely, if in future I can give a webinar to a larger audience, that will be wonderful. Yeah.
Yes, absolutely. We love that, Chitra. It would be my privilege. So I'm here to serve this community. That's what I want to spend some next few years of my life in, and this will require partnership. So I'm absolutely looking forward to engaging with the CS academic community in India.
Thank you, Sumit. Thank you.